Good evening everybody, it's from Jayshree. I'm going to take the number system and logic gates multiplexer. Okay, this is what the analog and digital integrated circuits is very main important topics for this analog and digital integrated circuits. Okay, the term multiplexer means many into one. Okay, multiplexing is a process of transmitting a large number of information over a single line. A digital multiplexer is a combination circuit that selects one digital information from several sources and transmit the selected information on the single output line. This is what multiplexer. The term multiplexer means many into one. Multiplexing is a process of transmitting a large number of information over a single line. A digital multiplexer is a combination circuit that selects one digital information from several sources and transmit the selected information on a single output line. Multiplexer is also called as a data selector. The multiplexer has several data input line and a single output line. So it has two hexadecimal digits, can represent either 8 binary digits or a byte. Okay. So must direct one of the inputs to its output line by using a control word to its select lines. Multiplexer contains the following data, that is data inputs, select inputs, and selection input determines the input that should be connected to the output. The multiplexer acts like an electronic switch that selects one from different. Okay, multiplexer, this is what the block diagram of multiplexer. D0, D1, D2, D3 data inputs and output, and S0 and S1 are the select lines. Okay, here this is what the 4:1 multiplexer logic diagram. S0, S1, that is what C0, C1, C2, C3, right? Here, this multiplexer forms this 0, 0. When go to this truth table, right? If it is 0, 0, okay. If it is 0, 0, the input D0 is go to the output. Okay. This is what here the symbol 0, 0. That is S0, 0 and S1, 0. And this input is C0. Okay, this you given as the output of this Y. In the first case is selected. Okay, 0, 0. In the second case, what is the second case? 0, 1. If S0 is 0 and S1 is 1, this 1 is go to the output. Okay, as Y0. That is Y. So here, this is what the combination of this circuit. Next, C2. C2 is nothing but 1, 0, 1, 0. Here this C2 is connected as the output to the output. Okay, why not? And this C3. This 1, 1. This 1, 1 is connected as this input of this C3 and this Y. Okay. So this is what this multiplexer 4:1 marks. To demonstrate this operation of the circuit, consider the case when S1, S0, 0, 0. If S1, S0 is 0, 0 is applied to the select lines, the AND gate associated with do will have two of its input equal to 1 and the third input is connected to D0. And the other three AND binary gates, at least one of these inputs which makes its output equal to 0. Okay. Here, hence the OR output Y is equal to the value of D0. Okay. And thus it provides a path from the selected input and data on the input D0 appears on the data output line. If S1 and S0 are 0, 1, the binary 1 is applied to the select lines. The data on the input D1 appears on the data output lines. Okay. If S1, S0 is 1, 0 is applied, the data on the input D2 appears on the output line. Similarly, if this is what fourth case. If S1, S0 is equal to 1, 1 applied, the data is D3 is switched to the output line. And the AND gates and the inverters resembles the decoder circuit, and indeed they decode the input select lines. In general, 2 power n to n 1:2 multiplexer is constructed from n to 2 power n to 2 power n decoder by adding it to the 2 power n input lines on each AND gate. So this is what the truth table of 4:1 works. If it is 0, 0, the output D0 is selected. If it is 0, 1, the output of D1 is selected. If it is 1, 0, D2 is selected. And if it is 1, 1, D3 is selected. Okay, thank you all.